Yeah, welcome to my session about healthcare for the elderly using the Internet of Things. This is about a little project that I started in the beginning of this year, and it's still ongoing, so it's not finished yet, and it's not a product, and it won't be a product, and it's just born out of an idea, and I will tell you about all the experiences that I had with this, building this stuff, and then using it because I use it every day. But first of all, let me introduce myself. So my name is Gerrit Grunwald. I'm working as a developer evangelist for Oracle, and on Twitter you can find me at @hansolo_. Don't forget the underscore, because there's another Han Solo, and that's not me. And because I'm working for Oracle, I have to show you this slide, which just says Oracle won't build any product based on these things that I will show you, and you have to read it, and I guess you read it already, so we just go on. So last year I was visiting a friend in Canada, and Canada is really beautiful, right? It looks like this. It's really you have all these farms and lots of area. It's just great, but it also comes with some problems, right? So one of the problems, and we also see it here in Germany, I think we see it worldwide, is depopulation on the countryside. So that means the countryside is less popular to younger people. And usually how it works is people move to the countryside, they have a farm, they start farming, then they become kids, the kids grow up, they hate it on the countryside because there's nothing to do, so when they grow up, they move to the cities, right? That's usually what happens, and then you can think about the result of that means many old people staying on the countryside, right? So the next problem is that, which is not really a problem, but somehow it is for this kind of things, is people getting older, right? It's not like in, 100 years ago where people maybe get 70 or something. Today people get 80. Some people get 90. So, and if you get older, you have more problems. So here's a little chart that I found based on data in Germany, and it's from 1995 to 2009, and you see that it's the population on the countryside really drops, and population in the congested areas just increases. So people tend to move to the cities. That's a trend, and it's for years. And if I would ask you, would you like to go and have a farm and do stuff? I bet most of you would say, no. Not really. So this is that's the problem. The next thing is on the countryside, and this is in Germany. It's not that big problem, but in Canada, and all this stuff is based on Canada. It's really a big problem because you don't have the same possibilities to access doctors, right, or healthcare services. So in rural areas, you usually have just half as many doctors as in the cities. And you have to go 5 times the way to the doctor if you're on the countryside. And then you can think about people that are 70 to 80 years old, and they have to drive with a car 5 times as far to just get to the doctor is a problem, right? And you also have fewer specialized healthcare services. So that means on the countryside, for the doctors, it's the same. Oh, not that many people coming to me and need my help, so it's better if I move to the city because they have more people and I can earn more money. So this is really, it's a bad situation, right? And if we look at the aging, I mentioned that already. This is what you dream of, right? This might be your future. But most of the times, or more often, it's like this, right? That means people are alone if they are old. Kids moving somewhere, and then if you have a couple, then one of those die, and then, for example, you see a lot of old women in some houses, and they're living alone for years. Kids are not there. And you have to face that, right? We will get to in that situation in a couple of years. So it's not an easy thing to think about that, but this is what it is. So people are alone, and what is in case of need? So if you are on the countryside, you have a farm, you're living there alone, and then you fall and you break your leg. So what happens, right? So and that was the trigger for me to start this project, because my friend, he has a farm, and he told me, my neighbor is 5 kilometers away, the next neighbor. I thought, 5 kilometers, wow. Yeah, and a couple of years ago, another neighbor, he just died, and nobody ever really figured that out. Just months later, someone just tried to call him and, what's wrong? And then he drove there and he found him dead, lying on the floor. And that's terrible. But this happened. So, and when I saw that and I hear the story, I thought, okay, now coming from the technical point of view, maybe we can make use of the Internet of Things to help those people in these situations, right? That was the main idea behind this project. And therefore, first of all, we need something like health indicators. So we have to figure out what could be an indication if a person is in good shape or not. And it's not that hard to find that out, because steps walked a day, so simple as it is, it's a really good indication. Because if people walking around means at least they are not lying in the bed or just sitting on the couch, they are really doing something. So that means they are in relative good shape if they walk a certain amount of steps each day. Then, and of course, if you have a wheelchair, you can also use the rotation of the wheels, right, as an indication if the person is moving around, right? So this is because if you have older people, some of them sitting in the wheelchair. Then another thing is the number of rooms you changed a day. That means walking from one room and the other room and back to the one room and then to the bathroom, to the kitchen and all that. So it could be an indication if you don't have the steps. Just see, okay, this person changed the rooms in his house for, 200 times a day. So let's say. And if he does like this, then it means he's moving around, so it couldn't be that bad, right? Then you can do monitor locations that the person visits outside, like neighbors, right? So if the person visits a neighbor each Tuesday, or for example, my grandma, she's going to the supermarket each Tuesday. Okay, so you can monitor that, and if this has some kind of a rule, right? So if this rule doesn't fit anymore because the person doesn't walk to the supermarket each Tuesday, then something might be wrong, right? This is the main idea, is figuring out situations where something might be wrong with this person, right? This is the idea. And we figured out time the TV set was running could be an indication, right? Maybe not in the US, because in the US most of the times TV set is running all the time. But in Germany, I tested that with my grandma, and the TV set was running around 3 to 4 hours each day. So this is something that you can monitor, and then you can figure out, you can create a rule out of that and figure out, okay, this drops at some point. Either the TV set is broken, then you can check the TV set, or something else is wrong, right? So it's a trigger. And there are many more, right? So it's this is just the stuff we did. And from these rules that you create, you have to create some alerts, right? Something like a dramatic decrease of steps, and then for a longer period. So that means if I walk today 20,000 steps and tomorrow just 100, no problem. But if I stay to 100 steps for a week, then there is a problem. Then something is wrong, right? You can figure that out. And if the same goes for the rooms, that if it doesn't change anymore, if the number drops and it stays low, and for example, TV set, same, right? If it's not running at all, or if the person is just not using it, then, like I said, either the TV set is broken or the person has a problem. Then we also have an alarm button that you know that this is available today. People can hang it around their neck and then just press a button, and then it will call a healthcare service or something. So we also have something like that. So this is of course an alarm, and because we can monitor the location, then we can also monitor if the person is outside or inside. And if you have something like person is outside and it's during the night and it's cold, you can monitor temperatures, there might be a problem, right? Then bad weather. Also, if you're on the countryside, you visit your neighbor, it's 5 kilometers away, and you walk back and it's in the night and it's very heavy snow. And then you see the person isn't moving anymore. Might be an alert, right? So all these things we try to monitor with this project. And there are many more. You can name it. It's really, we just thought about things that will fit for the farms in Canada. That was the idea. So in the end, everything you need to do is data processing. And that means we have, first of all, collect the data, then we have to aggregate the data, we have to analyze it, and in the end, visualize it, right? And do something with this. So let's start with the collecting. This is the more IoT part of this project, because collecting data, first of all, you need some hardware to collect data, right? And first thing and most crucial, without the internet, you can forget the whole project. This is as bad as it is, but without internet connection, the whole thing won't work. But in Canada, that wasn't a problem. We checked that, and they have a good coverage, about 95% of the rural areas where people live. They really have this 3G connection at least, so this is not a problem. In Germany, it's it's also quite good, but like countries like Asia, Africa, yeah, this is problematic. Or Russia, for example, they don't have a good internet connectivity outside. In the countryside, it's really sometimes problematic. So we use iBeacons to locate people inside the rooms. So that means the changing of the rooms. We use iBeacons. I will come to that in a minute, what it is. And accelerometers to count the steps. And then we have GPS to locate person outside. And a power meter to detect the TV usage. Right? You could also use the coffee machine if you like. Right? It's just a power meter that you can plug between some electrical device and the power plug, and then it will just measure the power that was drawn by this device. So iBeacons. Who knows what iBeacons are? Someone used it already? Just a few. Yeah, I use these iBeacons from Bluekey, but there are thousands of different ones. This have just because they're a little bit bigger and they have a really big battery inside, so this thing can run for 3 years on one battery, which is great. And you have also very small ones; they can run just a couple of months on a battery. But we have to install these things in the house, so that was the reason I just would like to do it once every 3 years. It's okay, change the battery. So it's a Bluetooth low energy device, and it just simply broadcasts a unique ID. That's in principle what it is. And you can adjust the interval of this broadcast, and also the transmission power can be adjusted. And with this you can create something like location-based actions, right? If you enter a room, then your phone, for example, or whatever device you have, detects the beacon, and then you can do something. And it's quite useful for indoor navigation. So I saw that this year at Mobile World Congress in Barcelona, they equipped the whole conference floor with beacons, and then they gave you a mobile app, and then you can locate you in the conference hall, and then you can say, I would like to see the booth of that company, and they navigate you inside using the beacons. So it's possible, but the accuracy is within 10-20 meters. So it's not really like GPS. It's not meters. It's more tens of meters, right? So and this is the setup that we use. So we have, for example, a floor plan of a house. We place the beacons in each room, one beacon, and then if the person just moves to the room, then whatever device it has, then it will detect the signal of the beacon, and then we know, okay, the person is now in this room. And the problem that comes with the beacons is the transmission power, right? If you see, each beacon has a radius of a range where you can see it, and then you have this overlapping areas here, and that's really bad, especially in this point. Here you will see all 4 devices at the same time. So in which room is the person right now? So what you have to figure out is how to adjust the transmission power in the right way, so that it really detects only the room where the person really is. And this is also, if you implement the software for that, you have to do something like, if you go into in the room and the first time the beacon was detected, yeah, a question? No, yeah, yeah, you can do that, but with the beacons you can do two things. First of all, you can just detect the signal, that's all, and then you can start ranging. That means you can detect the distance to the beacon. We don't do that because that draws a battery. Really, we really just detect the signal, and therefore this is the range the signal can travel, and you can adjust it by just adjusting the transmission power. That's the idea. So, and in the software that we wrote, it's really the first time you detect the beacon, we also keep every beacon you see. It's the like this. I'm in the living room. Then the device knows the current room is living room. Then the next time it sees, for example, kitchen, then we wait and until kitchen appears more than once and see, okay, now he's really in the kitchen, and then we change the current location to the kitchen. Yeah, so this you have to do, but it was not that hard. So with the beacons, you get some software, you can adjust it very easily. Yeah, so the first attempt was, let's build the stuff by ourselves, right? Why not? So it's fun. So based on this device, which is an Odroid W, which is not available anymore, I built this thing, and it was smaller than this one, maybe this a little box like this size, and that was the last edition with this GPS antenna. I also had different GPS antennas. So we built in a GPS sensor and Bluetooth low energy adapter to get the beacons. We had an accelerometer inside, and also the whole thing was running on Java SE8 embedded. It was fun and it worked for most of the things, but it was too clunky. So I couldn't put this thing to my grandma. Won't work. She was like, "Well, what's that?" Okay, forget about it. So it's too obtrusive. You can't really wear it. It's okay as a prototype, but that's it. And it was really hard to handle because you see it doesn't have any buttons. There was only one button to switch it on, and that's it. And there was no interactivity at all with the device itself. So we needed an addition phone or something to do that, which doesn't make sense. And the battery life was 7 to 8 hours. So this was just really the first attempt, and then when it was finished, we figured out, okay, it works, but it doesn't make sense. So we went further to the next attempt that was based on this device. And that was quite nice. It's a Kickstarter project. It's called Atomware. And fortunately, this company was based in Canada, close to the city where my friend lives. So he went there, and we talked to the people, and they showed us this stuff, and we bought 2 of those, and we have accelerometers inside, and we have Bluetooth low energy, and there's a tiny display here, you can't see it, and we have to code it in C. And it looked nice in the beginning, but in the end it doesn't really work out. So it it has no GPS, and it was really hard to handle and really not stable. And then there was no interactivity except this very tiny screen where you can maybe put one character on or something to make it readable to elderly people, right? So kids can read the small things, but even for me, it's like, what is it? Oh, okay. So that wasn't really good. So, and the battery life was a couple of hours, so not really useful. So, and then at the third attempt, and it seems so easy, just use the mobile phone. Bam, right? So I don't know why we tried all this stuff before, because that was really maybe because we have when we started there was this what is it, Google Fit, you know, some of you know that maybe it's the same as I think it's Apple Health or something from Apple. They have the same stuff. and when we started this stuff was quite new, so that kept us away from using the phone. But over the time, it's really now all this stuff is based on Google Fit, most of it, because you know, they can collect steps automatically, so you can ask them, okay, give me the steps. So if you activate it in your phone will collect steps if you walk. So which is really nice. So first of all, we have a 3D or 4G connection, which is great. Then we have Wi-Fi and Bluetooth Low Energy, so everything's there. We have a really long battery runtime, especially with this phone. So it's that phone here. It's a Sony, and the good thing is that the phone is it's water resistant. So, and that was the main reason. First of all, it's small. The battery really runs for 2 days. If you just use it with the program, it runs even longer than 2 days. And if I would use it, for example, with my grandma, then this would the only thing that they use it for is it's this program running on that phone, right? Because she's not like kids today, like I have to write some messages or Twitter or something. So that was really nice. And water resistancy is something that is, in my eyes, really important. If I have to tell my grandma, you can use that phone, but be careful with water, right? If it gets wet, then it's damaged. So that was the reason why we chose the Sony stuff, because you can even put it in the bath tube, and then it can stay there for 30 minutes without getting any damage. Then with this, we also had the watch. You see it here. It's a smartwatch. It's also from Sony. And when we started, we just used the phone, and then we started with this Android Wear stuff, and we thought about, okay, maybe that makes sense. And we saw the watch, which is again water resistant, which is great. So you can use it in the shower, and you don't have to take it off. And it has Wi-Fi and Bluetooth Low Energy. And Wi-Fi is really interesting feature with the Android Wear stuff. And this watch can also count steps. It has a GPS sensor inside. It has a really long battery runtime, which is important. And it interacts with the phone. And the nice thing is, it interacts with the phone even over Wi-Fi, over the cloud. So that means I can use the phone, leave it at home, and I can use the watch. And if they are both connected to some internet connection, they can talk to each other. So it means if I can trigger something like an alert call, it doesn't make sense if I have the phone at home and I'm here. But if you have the phone in your room, in the living room somewhere, then you can walk around in your house and you don't have to carry the phone all the time. And that's really useful, because if you just have the watch, then you can maybe convince older people to wear the watch, right? That was the main reason why we really stayed with the Google stuff, because with the Apple things, this is not possible as far as I know. That's really nice. Yeah, and it's water resistant. So the interesting thing is, and we will come to that in a minute, that I can trigger alarms from the watch even if I don't have the phone in my pocket. If the phone is maybe in the living room and I'm somewhere outside close to my home and still on the internet, then I can trigger stuff on the phone, which is really nice. Then we use this flick buttons, and you can buy it now. I get them from Kickstarter, but I think since 2 weeks you can also pre-order them. It's a Bluetooth Low Energy device, and it's really just a button. You can press it, and then it will send a signal, and it has a click, double click, and you have also a long click, and you can get pressed and released. That's the things you can do. And yeah, I don't know, the battery will run forever because it just sends if you press the button, so otherwise it just stays there. And we use it as alert triggers. And you can have multiple, right? So because each of them has this unique ID, so we can have a trigger in each room, for example. We can just push the button and then the phone will call someone or call for help. Yeah, we have multiple buttons possible. So this approach was really easy to handle, and we have Bluetooth Low Energy and GPS, and we have a long battery life, and the connectivity is not a problem, and interactivity, because we use a phone, also not a problem. So for the software, that wasn't so easy, because we have to detect GPS location and beacons. That's the easy part. We have to interact with the flick button, also not a big problem. Aggregating steps, you can do it by yourself, but like I said, with all this Google Fit stuff coming, we didn't have to do it anymore. So they do it, and they do a good job. So, and the good thing is, if you use the watch and the phone, both will collect steps. And then if you combine them again, then they will figure out what is the real the right value. So this is really nice. And we have to call a contact person, because I thought about my grandma. She calls, for example, my mom every day. right? And for stuff like, oh, I forgot where I put this thing in my kitchen. Do you know? Can you come over? So we needed also a contact person in case of something's wrong. So you have to have one person that you have to contact then, and we have to publish the data somewhere. So that are the requirements. And we start with the mobile application, and it looks not that fancy because it's for elderly people and it should be easy. So it's just two big buttons. It's just one button to call help and another button to really trigger an alert. And if you set it up with, you do that once with the person, the telephone number and the picture, and then it looks like this, right? So this is my wife, and then you see the picture, and then it's really easy for them. You can just take the phone, press the button, and the phone will do the call. And on Android, we have this widget stuff. And the good thing is you don't have to even start the application. You can put it directly on the screen, just a widget with a button like this. And then that's all you do. You just switch the phone on and then you directly can call a person or trigger an alert. And that is really convenient. Right? So this is what I really like a lot. And then we have to set up the beacons once in the application. You do that once and then that's all you need to do. So that's in principle the mobile app. And it can call a contact person, can send alert messages, and collect steps, detect beacons and location. And then it's something like, because we know if the person is inside or outside, we only use GPS if we are outside of the house to really save battery life. And the beacon stuff is really with the newer phones and Bluetooth Low Energy 4, it's not that not the big problem with the new phones. For example, if you have a Samsung Galaxy S4, I tested with this phone, and as soon as we use the beacons, it draws the battery like hell. On the Sony one, no problem anymore. So it really depends. If you have a newer phone, it's better. The older phones are not that good. So we implemented also a fall detection algorithm. So that means if you fall down, usually that's what happens if you have the G forces over time. That's normal, around 1 G. If you fall, in the moment you fall down, you get close to 0 G, and then if you have the impact, then you have a really increase in the G forces, and then it goes back to normal, a little bit up and down, and then it stays stable again. And you can detect that with the phones. So we have that in the software, and if you follow this this link and this QR code, you will find a paper that describes this algorithm that we use. And it also has posture recognition. That means we know if the person is sitting, lying, or standing. You can really figure it out from the accelerometer and the gyroscope. And that's quite interesting. So that means if the person has the phone close to the body and is falling down, we can detect that fall. And then we can trigger an alert if this happens. You can, for example, you can do stuff like the person is falling down and it doesn't move anymore. That it's a really bad situation. If it's falling down, the person, then you see, okay, standing up, moving again, okay, everything's fine. But the worst case would be the person is falling down and then you don't have movement anymore. And the hit rate is around 85% on that algorithm. It's not the best, but it's good enough, right? It's easy to implement. Okay, so the Wear application that is running on the watch, it's in principle a copy of the application that is running on the phone. It has just these two buttons, and they look the same and they do the same. So it can also send the alert message, collect the steps, and it interacts with the phone via Bluetooth and Wi-Fi. That's the stuff what I mean. If you can leave the phone, for example, in the kitchen and then walk around in your flat or in the house. And if both things are connected, you can still trigger an alert from the watch. And what it does, if you trigger the phone call, for example, it just calls the number and it switches on the loudspeaker on the phone. So if for example, if my grandma is falling down in the floor and the phone is lying in the kitchen, then she can trigger this telephone button, and then it will call, for example, my mom, and it will switch on the loudspeaker. So that means my mom can hear my grandma, and then they can talk even if the phone is lying somewhere else. That works for close distances. So it's stuff like that you have to think about, but it's possible. And then with the newer watch faces on Android, where you also have the ability to have a watch face that has a button. So we implemented this, and if you press the help, it will directly call someone in this case, or you can also use it for the alert. It depends, right? So stuff like this makes it really useful. So that's really nice ideas. Yeah, what's wrong? Oh, battery's gone. So if we take a look at the flick button, I mentioned that already. With this, we just have for all buttons the same. It's just triggering an alert. So you can put them wherever you are. And as soon as they're in range of a phone and you press it, then the phone can do something. In this case, it will do the same as if you press the alert button on the phone application. And it can interact with the phone via Bluetooth Low Energy. So that means you have to put it, for example, you can also put one in the car. That's what I did. I tested the whole thing for since June, and I have one in the car, and I monitor the location of the car by having the beacon in the car. Because as soon as I'm approaching the car, then the application knows, oh, now I'm in the car, then I'm moving around, and when I then left the car, because I can detect the position, and I see, oh, the beacon is not in range anymore, then I can save the position of the beacon, where the beacon was, so I know where my car is always when I leave it somewhere. So this is the Yoctowatt, which measures the power, and it's from a company called Yoctopuse. It's a Swiss company, and they really have nice modules, small, and for all different things, and you can hook them up to many devices. Really nice. And this is just we put it between the TV set and the power plug and just monitor the power consumption of the TV set. And it can interact with. They also offer something like a little Wi-Fi module, and then if you attach it to this one, then it can send the signal via Wi-Fi. So the mobile phone or maybe a gateway can directly monitor this device. So this is all the stuff that we use to collect the data. So now we have to aggregate it, and there are different ways to do that. And we started with this thing, which is an IoT gateway, and it's an ARM-based single board computer. And in this case, it's based on an IMX6 quad, 1 gigahertz, and has 4 gigs of RAM. So it's quite powerful device. And we use Java SE8 embedded to run the software on that. And what it does, it acts as a geofence server. So I will come to that in a minute. And also it aggregates data directly from the power meter and also via MQTT. And it filters the data that comes in, and it forwards data to the cloud or whatever, wherever you have it. And if we take a look at the geofencing, who knows what geofencing is? Yeah, most of you, I think. It's a useful thing. So in principle, it works like that. You have a map like this, and you receive the location, and then you create some fences. They are polygons in all cases. So because we implemented it by ourselves, if you use the features in Google Maps and other software, usually they use a circle around the position. But for us, that didn't really work because we would like to do things like a supermarket and whatever, a neighbor with a farm. So that's how we trigger if the person approached a neighbor. Right? We just create geofences around the next neighbor's farm, so we know the person is now at this place, and when he come back home, he enters his own home fence. And so I created a lot of fences and at my hometown, and it's really interesting if you see that, because if you then trigger, because I get push notifications when I move with one phone in a fence, and I cannot only because we keep the state, and that's the difference. So usually with the fences, you can say, someone approached the fence, but you never can tell, is he still in or not? And we can. So that means we keep the state of each fence. The fence knows how many people are in there, and they know when the people arrived, how long they stay there, and when the people leave, we also get a notification. So that means the geofence server is a little bit more advanced than the standard stuff. So it can react on entering the fence, leaving a fence, and also you can create rules like how long does the person is in the fence now. Right? It could be an alert. So for example, if you have my grandpa, he liked to go in the woods and just to walk there and pick up some stuff. And if you create a fence around the woods, for example, then you can also say, he's now for 6 hours there, and it's pretty cold outside and it gets dark. So You can do something with this. So it's really, you can do a lot of stuff with geofencing if you think about it. So then we have to aggregate the data, right? So this this little box, the gateway, it aggregates data directly from the TV set. So that means via Wi-Fi, it gets the information. Okay, now the TV set consumes that much power, so it's on. Then you can start collecting data. Okay, now it was on for 5 hours, for example. Then from the mobile phone via MQTT. MQTT, who knows MQTT? Yeah, it's a binary protocol, which is a publish-subscribe model and very popular in the IoT area. And it was invented by IBM, I think 10 years ago. And in the meantime, it's open source. And it's really, for stuff like this, it's really useful. And it also gets information from the geofence server. In this case, the geofence server was running on the gateway, but we also, in the meantime, for example, the geofence server is in the cloud somewhere. So it's not on this gateway anymore. So it has to filter data. And the problem is with all the sensors, you know, it's not always really reliable, the data that you get out of the sensors. And you have to filter it, you have to smooth it. So with the TV power, for example, you have these peaks in there, so it's not really the truth. And with GPS, you know that maybe. Sometimes you switch on your phone and then you are in Hawaii or something, and then whoops, it moves somewhere else. And this is stuff you have to filter out to really get reliable data, right? With the GPS, it's really, because the geofencing depends on the GPS location, right? And if the GPS location is wrong, then the whole geofencing doesn't make sense, because if you're at the border of the geofence, then it starts to jump, right? Inside the fence, outside the fence, inside the fence, outside the fence. You have to really figure out these situations and filter them out. Yeah, like here, it's with the geofence data. So if the GPS location jumps around, then also the geofence data starts jumping around with inside fence, outside fence, inside fence. So this is really stuff you have to filter, and that's not that easy. It really depends on the phone. For example, the iPhone 6 has a really extremely good GPS receiver, and the Sony phone is okay. It's not as good as the iPhone. So it really depends on the phone too. So it's interesting. Then if we have all this data collected on the gateway, we have to forward it somewhere. And what we do, we have that changed a lot. So we started with an application server based on Java that was sitting somewhere. We had a hosted server, and we published the data via REST to that server. In the meantime, now it's still a hosted server. Now it's Node.js, so we don't use Java EE anymore. So it's really, it changes a lot. But the principle is still the same. So we have once a day, the data will be stored. So with all, you can imagine that it might be sensible data, right? So if we monitor the location outside, who would like to be monitored, right? Not really a good idea. But what we really do is we just save the data once a day, and we only save the steps and the room changes, and that's it. And all the rest of the data is gone. It's just for live monitoring. In principle, it's really just for the system to monitor yourself and to figure out if there's a problem. And that's all we need the data for at the moment. So with the steps, we do some analysis, and also with the room changes. But I will come to that in a minute. So that was aggregating. Analyzing, and for analyzing data, it's first of all, if you have events, then in the beginning of when the event occurs, it has the highest relevance, right? But over time, this event becomes less and less interesting because it was just one little event. But if you aggregate all the events, then over the time, a lot of events become interesting, right? So this is that's an interesting thing that you have to keep in mind. And what we did, we created a simulation data set of about 5,000 people, 3 months of history, 5-minute event interval, and that was around 130 million events that we have. And we would like to figure out how can we monitor that and what can we use to do. And we use Spark. Does someone know Spark? Apache Spark? So we use that for analyzing data. We just started with it a couple of weeks ago, so I don't have a lot of information about that. But it's a general purpose cluster computing system, and it started in the AMP labs at University of California, and it was open source in 2009. And it's the engine is written in Scala with an API for these languages like Scala, Java, Python, and even R is now available. And it's a core engine that has different modules. And with these modules, you can do stuff like MapReduce, group by, fold join, all these functions that you can or that you would like to use on data. You have available in Spark, and you can use data from HDFS, from Cassandra SQL. You can use data from streams, even from MQTT data streams. That means if we stream the steps as MQTT messages into Spark, then Spark can use this data and aggregate it and analyze it. So, and in principle, this is the architecture of the system. So it's we have the Spark core, and then we have the modules for data frames and SQL, streaming, machine learning, and graph processing. And we use these two, streaming and machine learning. Where machine learning is really complex. It's not easy. This is where all the rules, you have to create rules for all this stuff and figure out the problems, because the idea is the system should monitor you, and then the system should figure out. Yeah, a question. You can ask a question, sure. Oh, it's not a database, Spark. This is really a system to analyze data. This is for analyzing. It's not for storing data. So you can use this the Spark engine to get data from your database and analyze it in ways like I will show it in a minute. So like take a look at this 130 million events and then filter out this stuff and apply this rule and that rule and then get a result out of it. That's the idea. So it's more for data processing. It's not for data storing. And it's an open source project, and it's quite popular at the moment. So if we bring it together, then this is how it looks like. So we have the devices on the left side. We have an MQTT broker, and then they send the data into the broker. Then it goes into the Spark system, the MQTT stream. And what it does, it will be processed. And then we have this historical baseline data frame, and then we can detect suspicious events. And how that works, I will tell you in a second. And normal events just go back to the historical data, and then the Spark system will just use it. And this anomaly detection algorithm, that's the interesting part here, because that's the stuff where we try to figure out if there is a dramatic situation or problem for the people. So let's assume a person walks usually 4,500 steps, which might be a lot for older people. So I don't know if someone records steps. Does someone use? Okay, so what are the numbers daily? 8 to 12,000. Yeah. So you can imagine that 4,500 might be for 80-year-old person quite a lot, but that was just a guess. And then there's another rule which could be usually a person is going to the supermarket every Tuesday. I mentioned that already, right? And stuff like TV set usage and so on. And there are more. So if we go to the steps, then we have for each person, and this is the problem, the system has to learn, because this is different for each person you monitor. And learning means it takes some time to figure out the right numbers. So we have an individual baseline, right? So it starts in the morning, we collect the steps over the time, and then we get this kind of graph. This is just how it could look like, right? This is a very ideal case. If we fill it with data, then this could be a typical day of this person, right? So it's in the range of the normal baseline. So that's okay. So if the stream for the day is like this, then in the beginning it's okay, and then at 2 p.m. somehow steps are dropping, so no steps coming in anymore. So then the system can go to this kind of, we name it attention state. So that, oh, wait a minute, something might be wrong. Just let's take a closer look at this person now. If it doesn't go back to normal and it stays for 2 hours, then and it's still low, then we know, okay, here is an alert, right? So this is how it works. And then if it's below normal there and where it's going flat, then we can trigger an alert, and the system can really do something. That's what the Spark system does. And we just tested that. At the moment, we are just testing this with this simulated data set. So it's not really on the live data, because we had some problems with the MQTT stream getting the data into the system. But with the simulated data set, it works. So we are figuring out how to do this. But the system, it is capable of doing stuff like that, figuring out, monitoring data, and then see, okay, here is something wrong, do something. And the do something could be call a REST service or something like this. So this is what we do for the data processing. And then in the end, we needed also this visualizing. So therefore, we created a desktop client. And the idea was this could be used by third-party healthcare service or whatever. So it was just to have something to show. So it's a Java client, and it shows the last known location of the person. It shows some additional information of the person and of the contact person, because if you have the healthcare service and you get an alert from your person that you monitor, then you might want to call the contact person first, because there might be something wrong. You might want to go there. Please go there, or contact your grandma or whatever it is, and there might be a problem. So this was the idea of the contact person, and it gets the data. We use server-sent events from the application server, and in the meantime, it's not a Java application server. I mentioned that it's a Node.js server, and this is what it looks like. So it's in principle what we have is we had at the baseline. Let me see if it works. Here we have a little chart that shows the steps. This is the data that's coming from the database. That's all we have in the database. Really just the steps for each day. And they will be stored directly before midnight, so we just collect them. So you can directly see, if you click on a person here, you see a map with the location, you see the steps, and see, okay, yeah, it's an okay. Then we have the average here. It's hard to see. Then we have data like this little heart indicates the current status. It just takes data from the last, I think, 10 days and compares them to the current state and say, okay, if it's over average or average, then it's fine. If it's below average for 10 days, then something is wrong here, right? This is also coming out of the system. And we have here the steps, we have the room changes. Here is the information of the contact person, like the name, the telephone number. Then we have also information about the battery of the mobile phone. Because if the battery is running low, my grandma maybe doesn't know how to charge it or when she should charge it. So the system will also trigger alerts like battery is running low. You have to charge your phone, for example. We have weather information. We see here if it's day or night. We have also something more like if we have the location, we have the geofences around the person. And then you see this path, because what we do, we collect all hospitals in a radius around, I think it's 50 kilometers for each person. And in case you have a problem, you can trace a route to this hospital, the closest one. And you can send this route, for example, to a driver. So we get really the routing information, and then we can send it to to a driver to send him the route on a mobile application. Say, you have to go this way from the person to the hospital, right? To figure out where's the next hospital, how far is it away, and stuff like that. How it works when you have the mobile phone, then this is the person, the mobile phone, and if now the person press the alert button, you will see here you have an alert sign coming up in here, and this can only be reset from this application at the moment. So the person with the phone can't reset it. It can, but it's hidden somewhere. So to avoid people pressing alert all the time, right? If you have the alert once, then, and MQTT makes sure that this message will arrive, because they have something like quality of service. And if you send the message with quality of service 2, then it really makes sure this message arrives at the location. So that's the reason we don't need the ability to have multiple alert triggers. So it's one trigger is enough, and then the alert is in the system. And then you can reset it from here. If this is a little button, it's hard to read. And if we press that button, then it will reset it on the phone remotely. So that means we can make sure that if the person triggers an alert, someone has to reset it on this system, right? Okay, so and at last, the setup of the system is like this. We have the devices and the gateway, and then an MQTT broker, and then we have the Spark system, and then we have an application server. And you see it gets complex. The visualization could be somewhere, and then it could also also be a third-party service that can be triggered. So this is the setup how we started, and it's Yeah, it's quite complex, as you can see. You have a lot of things you have to cover, and one of the worst things was the gateway. And so we decided to simplify because that was too complex. This is how it looked like in the beginning. And the first thing we tried to do is getting rid of Spark and the application server and put everything in the cloud. And you might know that Amazon came up with an IoT cloud service. Oracle will also come up with an IoT cloud service. So that means cloud services, especially for IoT, they come with inbuilt data analysis capabilities. And that will be the first step that we are working on at the moment. And we could simplify even more if we do this. And that's the final goal of the whole thing, is that the phone directly collects the data from the TV set, for example, and the phone talks directly to the cloud service, and everything's done in that cloud service, wherever it is. It could be, like I said, different companies are working on that. I think IBM is also working on something like an IoT cloud service. And with this setup, it's much easier because then you have just one point to talk to, and everything can be defined in the cloud service. And the conclusion is that after working with this since the beginning of the year, so the devices are really just too big. Right? Mobile phones are like this today, and I would like to see small phones, because you don't need all this stuff. I don't need a phone for web browsing, but I need the Bluetooth Low Energy stuff and all these things, right? So I need a touch display, but not that size for things like this. It should be small and lightweight. Then the technology must be more easy, definitely. It works if you know what you're doing, it's easy, but you have to set up the system for each person once, and that takes some time. And it's really problematic to convince people. So I talked to my grandma and tried to convince her, and she was like, no, I don't want to wear that stuff. I said, okay. So maybe if we get older, we are more into technology. There might be not a big problem, but today it's really hard. And data privacy and security, I have slides for that, but I have to skip that. It's not the time. This is critical, right? So it's critical data that you have here, and you have to make sure that this is really secure, in a secure place. So this is something you have to take care about that. And internet access. Once again, this is on the countryside. This is crucial. Without that, the whole system doesn't work. And that's it.